Assalamualaikum and very good evening. My name is Amir Zharif. We are from group 30. So we will be presenting our assignment B. To start with, we have choose our molecule methane, which is CH4. As you can see, we have the 2D and 3D structure for methane. For 2D structure, carbon as the central atom and it attached with 4 hydrogen atom. And for 3D structure, it has a tetrahedral shape. Next, for the chemical bonding, you can see that carbon attached with hydrogen atom, it has a covalent bond because the carbon atom attached to hydrogen atom, it is a nonmetal with nonmetal, so it is a covalent bond. Next, in fact, methane only consists two types of elements, which is carbon and hydrogen. As you can see, this is the structure of carbon and this is the structure for hydrogen. For the electronic configuration, carbon has a electronic configuration which is 1s2, 2s2, 2p2, while for hydrogen only 1s1. For the valence electron, carbon have 4 valence electron and hydrogen only 1 valence electron. Moreover, I will be explaining the position of the atoms in the periodic table. For carbon, it is located at period 2 because it has 2 orbits, and it is located in group 14 because it has 4 valence electrons. While for hydrogen, it is located at period 1 because it has only 1 orbit, and it is located at group 1 because it only consists 1 valence electron. But for the orbital, we can refer to the diagram below. So carbon, it is located at p orbital, and for the hydrogen, it is located at s orbital.
Okay, now we move on to type of chemical bond in methane. Type of bond is covalent bond. The geometry of methane is tetrahedral. Type of covalent bond is sigma bond. If we go specifically, the bonds present in methane is 4 carbon hydrogen bond, which is sigma bond. The number of bond in methane, 4 sigma bonds formed by the overlap of atomic orbital, and the formation, atoms share electrons to achieve a stable electron configuration. Okay, now we move on to type of chemical bond in methane. Type of bond is covalent bond. The geometry of methane is tetrahedral. Type of covalent bond is sigma bond. If we go specifically, the bonds present in methane is 4 carbon hydrogen bond, which is sigma bond. The number of bond in methane, 4 sigma bonds formed by the overlap of atomic orbital, and the formation, atoms share electrons to achieve a stable electron configuration.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Irfan bin Adi Setia. I would like to proceed our presentation by explaining the real-world application of methane. Firstly, methane is used as fuel for energy production, especially for electricity generation. As the major constituent of natural gas, alongside other mixture of gaseous hydrocarbons, methane is crucial as a fuel in an internal gas combustion, gas turbine, or steam generator. The relative abundance of methane on Earth makes it an economically attractive fuel, although capturing and storing it requires technical challenges due to its gaseous state under normal conditions for temperature and pressure. This trend will undoubtedly replace the dominance of coal as fuel. The most direct method to attain methane is through mining, which geologists and geophysicists must explore potential sites before drilling and extracting natural gas from underground reservoirs. This methane fuel is mainly applied in electricity generation. United States is a leading country of the most yearly natural gas consumption, approximately 27.25 million cubic feet (NMCF) followed by the Russia and China, 15.54 MNCF and 6.74 MNCF respectively. In Malaysia, there are 24 gas-fired power plants, including the largest Endera Melaka power plant, a combined cycle gas turbine (CCGT) power plant that capable of generating 2,242 megawatts of electricity to the country national grid. An alternative method has been popularized of collecting methane based on its biogenic characteristic, which is produced predominantly by methanogenesis process, a form of anaerobic respiration. This process is only known to be conducted by some members of this domain archaea called methanogens, mostly occur in landfill, soil, and ruminants. Thus, it is a beginning of sanitary landfill. The sanitary landfill is a method of disposing waste on land without disturbing the environment and public health, by efficiently utilizing engineering skill to confine them in the smallest practical area possible, before reducing the volume by covering with a layer of earth to ensure the least exposure to the air. It is suitable for municipal solid waste and non-hazardous waste. There are different level of layering of waste to facilitate the decomposition of the materials and trap toxic gases, methane included, released from the process. The third layer of this sanitary landfill will be the gas collection system. By this extraction, pipes deepened in this layer is aimed to trap methane gas and transport it to the treatment plants to treat the gas and thereafter use it to produce electricity and to power various processes. Moreover, Malaysia also intends towards neutral carbon emission as early as possible in 2050 and already has 12 sanitary landfill such as Bukit Taga Sanitary Landfill, where the produced methane gas at this landfill will be sold to the Tenaga Nasional Berhad (TNB). The second real-world application of methane is chemical feedstock. Hydrogen is well known as its widely application in various industries, mostly in petroleum refineries as well as chemical production, food processing, and industrial synthesis of ammonia to produce fertilization or explosive for quarry using a hybrid process. One of the methods to extract hydrogen from methane is steam methane reforming (SMR), or simply known as steam reforming, is the standard industrial method of producing commercial bulk hydrogen gas. More than 50 million metric tons are produced annually worldwide, principally from the SMR of natural gas. At high temperature, around 700 to 1100, and in the presence of metal-based catalyst, which is nickel, steam reacts with methane to yield a mixture of carbon monoxide and hydrogen, known as water gas or syngas. Additionally, hydrogen is obtained by the reaction of carbon monoxide with water via the water gas shift reaction. Other than that, methane pyrolysis is another method of hydrogen extraction from methane via the direct degradation of methane without producing any greenhouse gases. The heat required for the reaction can also be greenhouse gases emission-free. The heat source could be concentrated sunlight, renewable electricity, or burning some of the produced hydrogen. If the methane is from biogas, then the process can be carbon sink. Temperature more than 102,000 Celsius degree are required to break the bonds of methane to produce hydrogen gas and solid carbon. However, iron catalyst has been reported to be stable up to 700 to 1000 Celsius degree, making them get considered the best candidate to industrialize the methane pyrolysis. On top of that, iron catalysts are cheaper and environmentally friendly too, compared to nickel and cobalt catalysts. Methane physical properties: flammable in the presence of oxygen with its low heat of combustion around 891 kJ per mole. Produce a great quantity of heat per mass unit 55.7 kJ per mole with its lower molecular mass 60 gram per mole of which 12 gram per mole is carbon. Number 3, possess a light density around 0.656 kg per meter cubic that allows for smaller and lighter tankage, that is storage and transportation. Number 4, pure methane is odorless, making methane leakage more easily detectable by smell. Methane chemical properties. The most industrialized related factor of methane chemical property is its combustion reaction. Methane could be combusted completely in excessive oxygen that produce carbon dioxide and water, as well as it releases a large amount of energy. Consequently, that's why the LNG or liquefied methane should be combined by liquefied oxygen, which is then called metalox, to suppress fuel efficiency in rocket engine. The hydrogen synthesis methods, as mentioned just now, SMR and methane pyrolysis, are not based on this methane chemical property of combustion reaction. Unlike the combustion reaction, SMR does not involve the energy of methane with oxygen. Instead, it involves the reaction of methane with steam in the presence of a catalyst and requires a series of reactions involving the breaking and rearranging of chemical bonds in methane and steam molecules to produce hydrogen and carbon monoxide. Methane pyrolysis method is more likely revolve around the thermal decomposition, pyrolysis of methane at high temperatures to break it down into its constituent elements, namely carbon and hydrogen, in the absence of oxygen. Additionally, this method also does not produce heat but consumes heat moderately.